presented here 5 years ago, and it was much easier to find a parking lot, so that's a good sign, I guess. Great to see so many people here. I assume that many of you are after an early lunch, some of you are before late lunch, so it might be challenging. We'll do our best to keep you entertained. Do you know if there is an internet connection here, by the way? Let me just try to connect. I need the internet. Can we get sound? That's the beautiful sound of connectivity. It's a dial-up 56K modem. I guess most of you are familiar with it. It signals to us that we are going to connect to the digital world. It's quite exciting, quite difficult to imagine today with those devices that we will need to go through such a process just to connect, to check mails, or to go to Facebook. But this was part of our life not so long ago. So we are always connected today, but there is one thing to be connected, and there's a different thing to be fully immersed in an environment. That's a kind of a big difference. I don't think that there is any doubt that not so far from now, we'll have a fully merged environment where digital and physical will live together. Whereas the experience that we will have, it will be a combination of physical and digital assets. But this is not the case today. Today, we still need to decide where we want to be. Do we want to be in the digital world, on our computer, phone, or do we want to engage with the physical environment? And this is quite limiting. I had an opportunity to see a concert, and are you familiar with Hatsune Miku? Anyone familiar with Hatsune Miku? Oh, great, a few people here already. So for those of you who are not familiar, she's a rock star. She's 26 years old, 2 million followers on Facebook. Her picture is on the front page of the Clash magazine, a UK magazine, and her figure is actually imprinted on the Akatsuki spacecraft circling Venus. So quite a nice achievement for a 26-year-old artist. So let me share with you the experience going to such a concert. Thousands of people are going to those concerts, actually. Here she is. I forgot to mention, and you can see it now, Hatsune is a hologram. She was born as a hologram. She was raised as a hologram. And actually, she was just married as a hologram. No, seriously, a Japanese businessman spent a lot of money to get the right. But this is mixed reality. This is a place where people go to a concert to enjoy and to entertain themselves, and they don't care if what is standing in front of them is a physical person or a digital asset like Hatsune. It's quite amazing, and if you think about it, this is where we are going also in the enterprise market, and I will talk about it a bit more. But this might be a point that some of you will think, are we in the right session? So let me kind of reset back. My name is Aviad Almagor. I'm working for Trimble as a senior director of mixed reality and brain-computer interface. And for those of you who are not familiar with Trimble, maybe a short introduction. We're a global company, about 13,000 employees, and 5 main business units. Buildings, civil, agriculture, transportation, and geospatial. And we develop hardware and software solutions. On the hardware side, think about GPS technology, laser scanners, total stations, machine control, IoT sensors, talking about PTCs that we just saw. On the software side, it is typically end-to-end solutions to the market we serve. So if we'll take building, for example, we have design solutions like SketchUp, 3D modeling application. We have construction management solution and machine control solutions. And we have maintenance, and owner's portfolio applications. So covering the full life cycle of the industry. One of the main goals for us at Trimble is to connect, to bridge together, to merge the digital and the physical. Our customers are in a very aggressive process of digital transformation, but it is not enough to have the digital world developed. It's not enough to have those 3D models with all the details. We must bridge the gap between this digital environment to the field in order to provide efficiency and improve safety and quality. And this is what we are focusing on. And this is why we invest so much in mixed reality, because we see this technology as potentially transforming the industries we are serving. So you saw some versions of this graph which present the maturity of a technology. And certainly we were looking at this 5 years ago and we kind of restarted our investigation concerning mixed reality. And if you will compare this graph year by year, you will see the progress. But I would like to start by taking you 20 years ago, actually a bit more, 1998.
A collection of New Zealand's weird and wonderful inventions is being showcased at an international event in Christchurch.
Oakley might look a little out of place. That's because he's entering a whole new world. It uses software that's been co-developed by companies Aviad and Trimble.
This system's still in its development stages. They want to make it lighter, smaller, and cheaper. But to see more of this house, I need to put this on. It'll let me walk through the house, even look out the window at the real world.
So 1998, 20 years ago. The technology is not moving as fast as we want. It was not ready for the commercial kind of time. No one would like to go with a GPS antenna on his head and a heavy backpack. The performance was not good enough, the display, the form factor. But now, 20 years later, we do have devices which provide us enough capabilities to deliver real value. And this is where things start to change. We can deliver to the enterprise market solutions which can improve the safety, quality, and efficiency. So we restarted the journey about 5 years ago, working with Google on the Tango technology, working with Microsoft on HoloLens. And actually, in early 2015, we presented together with Microsoft the first proof of concept of how this technology can transform the industry. And from this proof of concept, we moved into pilot with different markets like mining and facility management, construction, architectural design, engineering, to realize what are the limitations of the technology and how far we can go with it. And this knowledge we got from the pilot helped us move into products. Today we have 5 different products, commercial products, shelf products, which you can consume already in the enterprise market for your needs. And we do expect, based on the experience we got so far, based on what we see in the hardware side and the software side, that there will be much broader implementation in 2019 and 20. So let's take a look, or before that, one note, we are completely hardware agnostic. We have a fantastic partnership with Microsoft, and we'll talk about it later. But we are working with Magic Leap on their solution, with Apple and Google AR Core, AR Kit, HTC, Oculus. Our solution can run on all those environments. And there is a reason for this. We realize that customers have different scenarios and different needs, different budget, different personal preferences. We want to make sure that what we deliver can support their needs. So let's talk about the first use case, starting with architecture, where I came from. And Greg Lin is a great friend and very knowledgeable architect from California. Greg was selected to represent the US in the Venice Architecture Biennale. And instead of presenting his content in the traditional way, 2D drawings and maybe 3D models on screen, he decided to use mixed reality. So this is the model that you can see on the screen. Pretty complex geometry, pretty difficult to understand just from drawings, elevations. So instead, we can bring the model into the reality. In this case, using HoloLens and presenting the model as a physical model on the table, which democratizes the design. Because now the owner, other stakeholders, the kind of community can walk around and look at it from any angle they would like to. And we can do more. It's not just about visualization. We can measure, We can query object to understand the materials or the cost or the schedule. We can enlarge part of the model to better understand and communicate specific details. And we can even go to an immersive mode, kind of virtual reality, where every step that we are doing in the physical world will be a step in this digital environment. So for architects like Greg Lean, Gensler, and others, this technology provides an opportunity to improve the communication with the client, to accelerate the design process, to better understand the implication of their design decisions on the overall design. So this is about communication. But if we look at the mixed reality use case, we'll see that there is more that can be done. And actually, if I'm kind of comparing, let's say, 2017 to 2019, we do see a shift. The technology is more mature, hardware and software. And more importantly, the customers are more mature. They know what to ask for. If about 5 years ago it was enough to put a HoloLens device or a Magic Leap device on your head and people would be smiling, wow, this is magical. Today it's not enough anymore. We need more value. Communication is critical, it's important, but it's not enough. And we would like to go into more challenging use cases like training, production control, quality control, and logistics. So we do see this shift already in the market, and I believe that we'll start to have this kind of balance between the communication and collaboration, which will stay critical, but with more advanced, more demanding use cases supported by the technology. And I would like to show you some examples for this. So the first one is a different form factor. This is a product called Trimble Sight Vision. And with this product, we can go outdoor. We can actually use it in an environment like civil projects. And what we can do here, it's a combination of a Trimble Catalyst antenna, which is a highly accurate positioning technology, together with a Google AR Core technology, providing the localization. When we marry those two together, we can get this kind of augmented reality experience, visualizing, in this case, the subsurface infrastructure, improving safety, quality, and productivity. In another use case with the same technology, we can actually have a heat map of the environment, in this case, kind of earth-moving use case. And one of the challenges in this kind of use case is to monitor and understand what's the situation, how much progress those guys did already. And with this heat map that you see on the screen on the right side, and in this video, we can actually visualize the differences between the two environments. So we get, from a tool called VisionLink and our sensors on those heavy machines, the conditions on the site. We send this to the cloud, and we bring back the information to the Sight Vision tool to visualize the differences between real and design, identifying any discrepancies. So again, a use case which supports the actual production process. In a similar way, Consolis, which is probably the largest prefab manufacturer in Europe, and what we are doing with them, we're trying to achieve a process which will completely transform the way they work today. It's about getting rid from the assembly drawings, assembly instructions. Instead, using mixed reality to what we call what you see is what you do. Just visualize the content through your lens and do the work. We're using markers here to make sure that the objects are stable, and we get today about 1 centimeter accuracy, which is enough for some use cases and not good enough for others. But certainly with this kind of technology, we completely transform the process. You can get sequences to support new employees, so they don't need to guess what assembly part should be done first. We can get quality control, understanding if the designed pipes can go through the rebar cage in this case. And this is, again, a great way to improve the quality and the productivity of the team. So for companies like Consolis and GA Smart Building from France, for example, this technology can completely eliminate the 2D process. And just think about it. They create very detailed model with 3D models in the computer. They spend huge amount of time turning those 3D models into a set of 2D documents just in order to build a 3D structure. If we can kind of streamline this process from 3D to 3D, we're doing something meaningful. And this kind of input from the customers, from the market, brought us to the conclusion that we need to invest more. And Trimble, as I mentioned, is a hardware and software company, and we have a good collaboration with Microsoft. And about 2 months ago, we announced at the Mobile World Congress in Barcelona the XR10, Trimble XR10. And this device basically takes the HoloLens 2, it's a HoloLens 2 based device, and provides the opportunity to frontline worker to bring mixed reality to the workflow. It's a very prosaic reason, safety. They cannot take mixed reality to the frontline environment without complying with the safety regulations. And this is a key kind of factor for them to be able to change their workflow. So that's a Trimble XR10. But there is more to kind of bring a bit more confidence to the picture. We do see a lot of synergy between mixed reality and other technologies in the market, other technology trends. It's quite rare to see one technology changing an industry. But if we have a set of technology working together, the impact is much bigger. And I will not go through the details of all of them, but 3D modeling is obvious. This provides the content. IoT, PTC spoke about it. Digital twins, computer vision to help us improve the accuracy of the alignment. AI and brain-computer interface, which I will talk about in a bit. I would like to show one example from our mining industry where we combine those technologies together. And what you will see in the video in a second is a mining engineer working on a mine, but the mine is actually on his office desk. So the geometry of the mine is coming from Trimble scanners on top of the rim. And you will see arcs representing materials, which shows where the material were taken from and where they are stored based on our database. You will see IoT information embedded in the process, and this can be done in a group session to analyze the situation. So here is a mine on the table, being up to date based on the scan. IoT information of the machines in the mine to understand who is the driver, how many hours the engine is working. You can enlarge the environment, look at the details, and even actually track the assets, the machines in the mine, based on the GPS and sensors which are included in the solution. So a complete mixed reality solution is a visual layer to all the other technologies that I just mentioned. Another example for the use of AI and mixed reality is the ability to track progress. I can compare the 3D design model to the actual environment and start analyzing the progress, compare a 4D model, which includes the schedule, to the actual progress on site, and do this color coding, which helps the superintendent to understand where the project is regarding the schedule. So if we'll look at the mixed reality, we have three main components here for the picture. Devices, like Trimble XR10 or other devices is one. The content, 3D model, the second one. And the third one, which we take for granted, it's out there, is a context. But this actually is the most important part. Because with mixed reality, what is important is the relations, and we can see them in the context. Now, when we talk about context, you can, I guess you imagine what we already saw. A mine, a construction site, your living room. But context can be kind of analyzed in a different way as well. You can look internally. So for example, look at those three figures here. We don't know much about them. But if we can get access to their brain, if we can get access to the EEG activity, we can start learning a bit more about what's going on here. And this input can give us an opportunity to improve the service, the game, the task that they are performing. We can understand how much they are engaged in the task, fatigue, any risk issues, and so on. And this brings us to a whole new area of brain-computer interface, which, as I mentioned, is quite relevant for mixed reality and augmented reality. And at Trimble, we are focusing on three main topics and collaborating with other companies on the brain-computer interface front. The first one is about safety. And again, I will not have a full deck here about brain-computer interface, but I would like to give you a taste of what this is and where it will take us. So fatigue monitoring, I mentioned transportation as a major industry for Trimble, and truck drivers, those long-haul truck drivers driving from West Coast to East Coast are a main risk. It's kind of challenging. And we want to make sure, we want to provide predictive tools to those drivers and to the organizations, which will tell them 10 minutes before they're actually falling asleep, hey, there is an issue here. We can monitor their brain activity, understand that there is an issue, that in 10 minutes from now they will lose their ability to resist sleep, and provide them advance warning. So that's brain-computer interface regarding the fatigue monitoring. The second thing is about being able to interact with content. And I'm talking about digital content, of course, for example, navigating in a model just with your mind, something we did with a company called Neurobel, and I will talk about them in a minute. Or activating and controlling physical assets. Kind of, you can intervene in an autonomous situation where the device is not capable of solving a specific problem. You can decide for the device, and brain-computer interface can be very useful here. And I'm talking about interaction because this is critical for us. Think about mixed reality. The world is our GUI. The command, the assets are all around us, not anymore in a screen. So if we can control those assets with our mind, that's something meaningful. And last, insight the user, into the user mind. How much he is engaged. What is a cognitive workload? And this can help us with games. For example, I see you're bored, I will push more tasks to your hands, so you will be engaged with a game. And it can help us with, for example, evaluating architectural work and understanding, getting insight into the user experience when he is visualizing a virtual design. I mentioned Neurobel, and they are our partners for this journey. They are experts in this kind of identifying and understanding the brain activities and being able to translate the brain activity into something meaningful. And what you can see here in this slide from the Neurobel environment, this is a SketchUp model, a Trimble SketchUp model, but this SketchUp model is being visualized by a user. You can see the raw EEG on the bottom right side, and then the translation of this to specific meaningful kind of events or meaningful information for us as users, for example, stress or attention or calm and so on. And this can really help us understand and present several design variations and based on this, improve our design. So I do want to keep a few minutes for questions. I will stop here and be happy to answer. Thank you very much.